Hey, what's up guys? This is Guy here with KB Trainings. Welcome to the chapter number 2.2 in which we're going to talk about VLANs and the trunking mechanism. And VLANs are very important in a network. You can have multiple customers and have each customer in a certain VLAN, or you can have like multiple departments in your company and each department will have its own VLAN. So there are many advantages or many benefits for setting up VLANs in your network. And we're going to see that in this chapter and also talk about trunking, which is just having multiple VLANs going from a switch to another switch. And the lesson number 2.2.1, we are going to introduce the virtual LANs. VLANs stand for virtual local area networks. And in this lesson specifically, or in this course, we are going to focus on the 802.1q, which is one of the tagging protocols that exist out there. And Cisco wants us to learn 802.1q only. There is another one called ISL from Cisco, that is Cisco proprietary, but 802.1q it's from IEEE, so it's public, it's universal. You're going to see it with many different vendors, but ISL was just for Cisco, so it's not really important anymore. We're not going to cover it on this course. So we're going to focus on the 802.1q, and I'm going to introduce you to VLANs, and we are also going to do some practice, of course. And these are the different contents, and we are going to refresh ourselves or refresh our mind on the broadcast domain. What is a broadcast domain? We talked about it in our section on the introduction to networking. We talked about a broadcast domain, but I'm going to tell you what the VLAN is bringing to the broadcast domain area and why is it very important. So we are going also to do some practice with the broadcast domain in Packet Tracer. Of course, we always use Packet Tracer for practice in this course, and we are also going to add some sniffers. You've seen me using sniffers in this course many times, so this is not going to be new to you. And we are also going to configure VLANs in Packet Tracer, and this will show you how the VLAN configuration will split our broadcast domain into 2 or more broadcast domains, and that's what VLANs are for. So we're also going to talk about the VLAN tag, the 802.1q. We're going to talk about the format of the 802.1q tag, and I'll give you some benefit of having the VLAN in your network. And we are also going to talk about different VLAN ranges and some commands that we are going to use. So to start off, by now you should know how to define what a broadcast domain is. If you have a single network and all those like devices on the network are connected to each other, those devices are part of a broadcast domain. Because if one of the devices sends a broadcast traffic, that broadcast is going to be sent to all the devices inside that network. Let's say we have a switch here and we have 4 computers connected to the switch. I'm going to do this in Packet Tracer, but this is just an overview. We have A, B, C, D. And because this is a switch, you should know that all the ports on the switch are part of the single broadcast domain. So if the computer A sends a broadcast traffic, for example, let's say ARP, because broadcasts are very important in a network. So like ARP, for example, will help you resolve from an IP address, will help you get the MAC address. So if you have an ARP request in your network leaving the computer A, because it's a broadcast, it's going to be sent to C, D, and B. So all the computers in this network are going to receive that broadcast. And that can be not so convenient. And if we don't want C and D to see the broadcast from A, let's say C and D are from a different department in our company. This is the IT department, and A and B are in the finance department. If we don't want the broadcast from A to get to the IT department, we can put these computers in 2 virtual LANs. That's why we call them VLANs. So this single switch is going to be virtually split into 2 different local area networks in a way that if A sends a broadcast traffic, that broadcast will never go across and be delivered to C or D. The broadcast is going to be seen by B, and we're going to see in this lesson what are the advantages of having a setup like this. So let's go in Packet Tracer, and I'm going to show you how we use VLANs to separate traffics inside a single switch. So we're going to build our quick topology here with one switch and four desktops. So I have my switch right here, and now I usually like to put the first laptop or desktop here because it's PC0. It always messes me up. I want to have the PC1 here, the PC2 there, the PC2 should be here, PC3 over there, and PC4 up there. And we're going to use sniffers on the PC1, PC4 and the PC2. So you're going to see exactly how the traffic is going to be or not be in that link. So I'm going to connect my different equipment to the switch. The PC3 and PC4 going first to the sniffer, and from the sniffer to the PC4. And my network is actually going to be a 10.0.0.0/8. Of course, this is what we usually use here because it's just simple to set up. And let's configure the sniffers. So we're going to listen to the port 0 because it's connected to the switch. So we go under here and make sure it's port 0, and we clear everything, and we only select ICMP. All right, so there's nothing here, and I can leave it up and put it on top so we can see what's happening in there. And we also have the sniffer 1. We're listening to the port 0. I deselect everything except ICMP, and then I clear the output so we can put it here and see what's happening. Let me put this on top as well. And let's configure our PCs very quickly. The first one is the 10.0.0.1 with the default subnet mask. The second one is a 10.0.0.2, the default mask. The third one is 10.0.0.3 with the default mask. And the last one is a 10.0.0.4 with the default mask. All right, so right now we have a single switch. We have all the devices connected to the switch. We have a single broadcast domain. So if there is a broadcast leaving A or PC1, it's going to be delivered to all the devices in this network. And we don't want to look at the broadcast now. You know what it is. You can do it. Now, I just want to show you that from the PC1, I'm able to ping all the different PCs. So if I do ping 10.0.0.2, I can ping it because we are in the same network. And if I want to ping 10.0.0.4, we can ping it because we are in the same network. We are in the same broadcast domain. So now let's configure VLANs on this switch. I know I usually like to show you exactly what it is, and from there, we can then go deep and understand exactly what we did and how it works. So I'm going to open the CLI on the switch, and from here, I'm going to do the VLAN configurations. Before doing that, let's do the design first. What are we going to do exactly? So we're going to have two VLANs. The first VLAN, I'm going to call it the blue VLAN, and it's going to be blue right here. So these computers, no, I think I made a mistake. The fill color should be blue. So these computers will be in the blue VLAN, and every VLAN has a number that is very important. It's called the VLAN ID. It goes from 1 to 4095, and I'm going to show you why we have that range from 1 to 4095. But for now, just know that every VLAN has a VLAN ID. So we have the blue VLAN. We have the blue VLAN with the ID of 20. We also have a red VLAN. I'm going to set the fill color to red and bring it here. So we also have the red VLAN that has the name of red VLAN, the ID of 10. So the computer number 3 and 4 are going to be in the VLAN 10 or the red VLAN, and the computer 1 and 2 are going to be in the blue VLAN or the VLAN 20. So let's go back to the switch and finish that configuration. All right, so here we are in the switch, and let me show you something. If we do show VLAN brief, you can see that when a switch comes, when you have a brand new switch, you just have a single VLAN on it, which is called the default VLAN, and that's the VLAN number 1. And all the ports on our switch belong to the VLAN 1 by default. So that's why it's called the default VLAN. You also have these VLANs here, 1002 to 1005. These are legacy VLANs that are there for, I don't know, maybe compliance reasons or compatibility reasons, but we don't touch them. I've never touched them. So you will never have to deal with those. But know that the VLAN 1 is the VLAN by default. So now we're going to create the VLAN 10, which is the VLAN blue, or no, red. And we're also going to add the VLAN 20, which is the blue VLAN. So how do we create a VLAN? I'm going to show you two ways. The first way, you can just declare the VLAN. Let's say VLAN 20 or VLAN 10. So if I'm here and I do show VLAN brief, you can see that we already have another VLAN added here, which is the VLAN 10. It's active, but there is no port in this VLAN. All the ports are still in the VLAN 1. So now that we have created the VLAN 10, we can even give it a name. Let's give it a name here. We can do name red. And if we do the command, we're going to see that we have the VLAN 10 named red, and there is no interface in it. So what we're going to do is add some interfaces to this VLAN, and we know that we need the interface fast Ethernet 0/3 and 0/4 to be part of this VLAN. So we're going to the interface fast 0/3. From here, we do the command switch port access. So the switch port, or this port that we're talking about here, the one that we're configuring, is in the access mode. And I'm going to show you different modes that you can find on the port in the next lesson. So this is in the mode access on the VLAN 10. If I do show VLAN brief, you can see that we have the red VLAN, which has one port in it, and this port is not in the VLAN 1 anymore. And let's go ahead and finish the second port. Interface fast 0/4. We do the same thing, same command. All right. And if we do show VLAN brief, you can see that we have our two ports that are in this VLAN here. This is one way of doing it. There's also another way. Let's do it for the VLAN blue or the VLAN 20. We go under config, and we can just go inside the interface and assign it to a VLAN. And if that VLAN is not inside our network, it's going to be created. So if we go in, and I'm going to show you how to configure multiple interfaces at the same time. This is what you use. You use the range command. So you can do interface range, which means that we're going to use more than one interface, and it's going to be fast Ethernet 0/1 space dash space 2. So which means that we are going to configure at the same time the interfaces 0/1 and 0/2. We click enter. From here, we can say switch port access VLAN 20. And once we do that, let's see, switch port access VLAN 20 without this. And once we do that, it says access VLAN doesn't exist, creating VLAN 20. This is a command that's creating the VLAN. So now if we do show VLAN brief, you can see that we have the VLAN 10 and the VLAN 20. The VLAN 20 doesn't have a name. Let's give it a name. So from here, we do VLAN 20 and we give it a name of blue. Oh, this is in French. Blue. So now we can do show VLAN brief. You can see we have the VLAN 10, the red VLAN, and the VLAN blue, which is the blue VLAN. So now let's go back to the PC1 and see if we can reach the other computers that are in the VLAN red. And I'm gonna tell you right away, we are not going to see them. So if I want to ping 10.0.0.2, I can ping it because it's in the VLAN blue. I can see it. The broadcast can get there. My IP traffic can get there. But if I want to ping the 10.0.0.4, I cannot reach it because it's now part of a different VLAN and there's no way for me to reach it. Like for example, if the red was the IT and the blue was the finance, someone from the blue VLAN will never see the traffic in the IT department. And this is just on a single switch. We may even have a different switch here, and I'm going to do that in the next lesson. I'm going to add the switch because I need to show you the trunking, which is where you have two different switches connected, and the link between those two switches is passing more than one VLAN. That is called trunking. We're going to see that next. So yeah, this is how you do it. This is accomplished by adding a tag. There is a tag that is added to every frame. And in our case, we had the VLAN number 10 and the VLAN number 20. So we had these two tags added to the frames inside the switch. And I'm going to show you what is the structure of this tag that is added to the traffic. And I told you that we are only going to focus on the 802.1q tagging protocol. Cisco also has ISL tagging protocol, but for the CCNA, we're not seeing ISL. We are only going to cover 802.1q, which is an IEEE standard. So it's from IEEE. And this is the structure of the tag that is going to be added. The tag has a total of 32 bits. You can see we have two 16-bit ports. And the first one, or the TP ID or tagging protocol ID, this one will tell you what is the tagging protocol that we are using for this tagging process. And because we're dealing with 802.1q only, this is the code for 802.1q for this field. And the next field is actually a set of these three fields. The first field is the priority code point. This one will give you the class of service or frame priority level for your frame. We're not going to focus on that because it's not really relevant. And the second field is the drop eligible indicator. So this will tell you if the frame is eligible to be dropped, if there is any congestion in a network. We're not going to focus on that. And this is just 1 bit. And the third field in the tag is the VLAN ID. This is the most important tag or the most important field because it gives you the number that you're going to see everywhere. When you talk about VLAN, you need to mention the VLAN ID or what is the VLAN number that you're trying to refer to. And this is a 12-bit field. And because it's 12-bit, we can only have 2 at the power of 12 combinations. So we have 4096. And you need to know that the VLAN 0 and the VLAN 496 are reserved. No. VLAN 495 are reserved. So we can only use 1 to 494. So we're going to talk about that a little bit later. But let me show you exactly the structure of the VLAN tag. And this is our regular Ethernet Ethernet frame. You should be familiar with this here. Just a regular Ethernet frame, just like we've seen it. And the VLAN tag is going to be located right here between the source address and the type or length. This is where the tag is going to be added. And you need to know that some frames are tagged. They have tags in them, and some of the frames are not. And I'm going to show you what the difference and how you can call them. So this is the tag. We said that the first 16 bits are the TP ID, and it will show you what protocol we're using. And as I said, for the CCNA, we're just going to focus on the 802.1q. And then the next 3 bits is going to be for the priority. And this field will tell you if it is eligible to be dropped or not. And the most important one is here, the VLAN ID. As I said, 4096. We don't use the last one. 4096 combinations going from 0 to 4095. And we don't use 0 or 4095. So this is the VLAN ID. And I'm going to show you in the next lesson when I will have two different switches. I'll show you I'm going to capture a packet between those two switches, and I'm going to show you what the tag looks like and why we use VLANs in our network. Just like we did in an example that I showed you, VLANs are very important because, first of all, they help reduce, I can't say first of all because benefits are all over the place. Just like I said, depending on the book that you read, you may have 3 benefits, you may have 6, or you may have 10. I can invent some more benefits. Don't forget that I'm going to leave you the link to the Cisco documentation, so take your time and read what Cisco is writing about this. The VLANs help reduce the size of the broadcast domains that we have in our network. And this will help reduce the broadcast traffic. So if a device is sending a broadcast, it's going to be limited in a certain area of your switch or of your network. All the other devices that are not in the same VLAN will not going to see that broadcast, and that's a good thing. It's going to increase security by segmenting the traffic, protected not in the Cisco way, like not in the VLAN way, but in the security way, where you need to do routing between different VLANs. So at that level, you can set a lot of kind of security ways to protect your traffic, or a little kind of block or access requirements. You also have an easy design when you can group your different users into different segments, and the different segments can be different departments, can be different classrooms, or by many ways you can have a single switch and have those different users being allocated a certain portion of that switch, and they'll just see each other. So yeah, these are the 3 main ones. That's why I put the three dots here. You can add more depending on what you read and where you read. And again, if you know what the VLANs are, and if you understand exactly how it works, you won't have any problem if you get this kind of question at the exam. You're going clearly to see what really doesn't fit if you have a multi-choice question about these VLANs. All right, so what are different VLAN ranges? First of all, you need to know that we have 2 main ranges of VLAN. The first one is the normal range, and the second one is the extended range. So the normal range goes from 1 to 1005, and the extended goes from 1006 to 4094. For the CCNA, we are just going to focus on the normal range. We're not going to study the extended range, but just know it exists. And we have 0 and 4095 because I told you that we have this many combinations if we have 12 bits. And 0 and 4095, which is the last and the first numbers, are not going to be used. They are reserved for the system only. The VLAN number 1 is the default VLAN. This is where all the ports are when you have a brand new switch without any configuration. This is the default VLAN. You can use it, but you cannot delete it. This is part of the system as well. So it comes with the switch. It's always there. You can never delete that VLAN. And the VLAN going from 2 to 1001, these are still normal VLAN, but they are used for Ethernet VLANs. Of course, this is what you can create, you can delete, you can add, you can do all kind of things with these VLAN IDs here. And we also have the 1002 to 1005 for the Cisco. These are still normal VLAN, but they come by default in a switch, just like I showed you, and they don't really serve any purpose. At least personally, I've been in production for years. I've never had to deal with 1002 to 1005. So these are just there for some reasons. We don't have to care about them right now. And these are different commands that I used in this lesson. I did the show interface status. Did I do it? Maybe not. Let me go back to the switch. Show interface status. You can see that it shows me some useful information. I can see all the different ports that I have on the switch. I can see what is the status of the port, and I can also see what VLANs or what VLAN these ports belong to. And this is very important if you want to see the layout of your network. And Yeah, that's the first command. The second one, the show VLAN brief, as I said, it's also very important. You need to see the summary of your VLANs on your switch. You do show VLAN brief. It shows you all the different VLANs that you have and everything. And we also have this command, the switch port access VLAN number. This is what we used inside the interface to assign it to a VLAN. We also have this last command, which is the default interface. This command is helpful because you can revert any interface to its default configuration. Let me run it here and we're gonna be done there. So this is the switch, and I just showed you that these ports are in this VLAN, or these interfaces are in these different VLANs. So if I do conft or configure terminal, and I say default interface range, let's say fast Ethernet 0/1 to 4. Look at that. So it says that the interfaces have been set back to default. And if I do show interface status, you can see that these ports are now back to the VLAN 1. And if I go in, if I do show VLAN brief, you can see that we still have the VLANs, but there is no port in these VLANs. So this is how you do it. And don't forget to read the links that I'm going to leave in the description. And if you have any question, go in the forum and ask, and I'll be glad to respond. And thank you so much for watching this lesson. In the next lesson, we're going to see or go deeper in the VLANs. I'm going to talk about the different types of ports, and we're also going to do some captures between two switches and show you exactly what the tag looks like. Thank you, and I'll see you in the next lesson. Take care. Bye.